Hello everyone, I'm Siddharthan. It's been a month since I last uploaded my videos in YouTube, and it really feels great to be back. I hope every one of you is doing fine, and thanks a lot for waiting patiently for my videos. So let's get started with today's video. In today's video, I would like to explain you about two main important parameters that we have when it comes to training a machine learning model. So these two parameters are model parameters and hyperparameters, and understanding this will really help us when we are dealing with individual models in detail. So in the subsequent videos, we will be discussing the intuition behind the different types of model that we have and how we can build these models from scratch. So it's a good idea to discuss about the parameters before going to that part. So that is the idea behind this particular video. So let's get started. So as I've told you, the two main types of parameters that we have in machine learning are model parameters and hyperparameters. So I'll give you the definition of these model parameters and hyperparameters. Model parameters are the parameters of the model that can be determined by training with training data. So these can be considered as internal parameters, and the two important model parameters that we have are weights and biases. Okay, so this is the definition of model parameters, and the two model parameters are weights and bias. Now let's try to understand this definition. So in my previous videos, I have made several videos on the topic linear regression, right? And we know that the equation of a line is y is equal to mx plus c. So I have written the same equation here. I have just replaced m with w and b with, sorry, the c with b. Okay, so y is equal to mx plus c is written as y is equal to wx plus b, where m represents the slope and c represents the intercept. So I have replaced m with w and c with b. So it's actually the same thing. Now we know that whenever we are training a model, we will try to fit this particular model to the data that we have, right? Say for example, let's say that we want to build a model, build a linear regression model that can predict the salary of a person based on their number of work experience. So in this case, y will be the salary of the person and x will be the number of years of experience for that particular person. Okay, so what we will try to do is we will try to fit this data. Let's say that we have about 100 data points, so we have a data of 100 different people regarding their number of years of experience and the salary that they are making. So we will try to fit this particular data to a linear regression model. Linear regression is nothing but a simple straight line. Okay, so in that case, we will get a straight line with some parameters. So it will be y is equal to mx plus c, and for that particular data, we will get some slope value. Let's say that the slope value is 30 or something, and we will get some intercept value. Let's say that intercept value is 3 or 4 something. Okay, so these can be any values. This slope and intercept value, m and c value, varies depending upon the data. So it won't be a constant in all the cases. So this particular values differ in all the cases based on the data that we have. So in this equation, as I've told you, the m is replaced by w. So the slope is replaced by weights and the intercept is replaced by bias. Actually, these are the same things. So slope and weight represents the same thing, and intercept and bias represent the same thing. So I'll tell you how this is. And now you can see this definition again. So these are the parameters of the model that can be determined by training with the training data, as I have explained you in this example. So we will get this slope value and intercept value after fitting the data to our model, right? So the model parameters are those which are obtained after training the data. So hence these are considered as internal parameters because these are the parameters within the model, right? So these are the parameters of the model. So for a line, the two parameters are slope and intercept, or you can call this as weight and bias. So these two will be the model parameters, and we can call this as internal parameters. Now let's try to understand about the hyperparameters. Hyperparameters are the parameters whose values control the learning process. These are adjustable parameters used to obtain an optimal model, and hence these are called as an external parameters. Now let's try to understand this particular definition. So whenever we are fitting a set of data to a linear regression model, what we will do is we will try to iterate the process. We will try to fit the data multiple times in order to get the best values for the parameters. So in this case, we have the weight value and bias value, right? So we won't get the best values for this weight and bias. So there may be some errors. So error in the sense, let's say that we get a linear regression model with some value for weight and some value for bias. So this model cannot make better predictions. So in that case, what we will do is we will try to optimize the model to get a better accuracy score to make better predictions. So in that case, what we will try to do is we will try to reiterate the model with that particular data. So we will try to fit the data again and again to the model until we get the best value for weights and biases, which can give you accurate prediction. So in that case, what we will do is we will try to manipulate the values called as hyperparameters. So example of this hyperparameters are learning rate and the number of epochs. So every time you reiterate the data, what happens is we will try to change the values of weights and bias slightly. Okay, so we will try to give a slight variation to the weight and bias, and we will try to check the prediction of the model. Okay, if the model make a good prediction, then we can say that it is accurate model. If the predictions are not proper, then it is not very accurate, right? So there will be a particular change in the values of weights and biases in each iteration or each process that we do. And this change that we are giving is called as the learning rate. Okay, and number of epochs represents the number of time we are training the model with that particular data. Let's say that we have about 10 iterations, so we want the model to go through the data 10 times. So in that case, the number of epochs will be 10. Okay, so this is about the learning rate and number of epochs, where learning rate represents the amount of change that we are imparting to the parameter values, and the number of epochs represents the number of iterations that we want. So now you can see the definition again. So hyperparameters are the parameters whose values control the learning process. So learning process is fitting the data to the model, and these are adjustable parameters because we can adjust the learning rate and the number of epochs. So we can manually give the value for learning rate and number of epochs, whereas we cannot give the values for this weights and biases. The model has to determine the value of weights and biases depending on the data. So that is the difference between model parameter and hyperparameters. As I have told you, it is used for finding an optimal model. So an optimal model is something that make accurate predictions and better predictions. So this is the use of hyperparameters, and these are external parameters because they are not within the model. So these are not the parameters of the model, but we are giving separately. So we are giving manually these values of learning rate and number of epochs. So these are the two different types of models that we have in model parameters, sorry, in machine learning models. So one is model parameters, which are the parameters of the model, and then we have these hyperparameters, which which determines the learning process. So how much change do you want to give to your weights and bias, and how many number of iterations do you want to give to your model. Okay, so these are the two main important parameters that we have. And apart from this learning rate and number of epochs, we also have some other hyper parameters, but these two are the main things that we will regularly use. Now let's try to understand about these weights and bias and learning rates and number of epochs separately. So weight. So what is meant by the weight of a model? So I'm sure that if you are trying to learn machine learning for some time, you would have come across these words, weight and bias, but you may not have a clear understanding of these two terms. Now let's try to understand them, and these are very main important concepts when it comes to machine learning. So weight is a value. So weight decides how much influence the input will have on the output. Okay, so just read this definition again, and you can take a note of this. So this is very important. So in a data set, we may have several features. So and you can have a target variable as well. Let's say that let's consider this particular data set. So in this, I have given data regarding an applicant for a job. Let's say that we are building a machine learning system that can predict whether a person can get a job or not based on some parameters, based on some features. So in this data set, we have the name of the person, the degree that they have, their educational qualification, and the college from which they have studied, whether they know C programming and whether they know C++ or Python, and what is the height of the person, what is the weight of the person, and number of backlogs, whether they have any arrears or not. So this is the data that we have. So how many features do we have here? So one is name, degree, college, C++, Python. So 7, 8, and 9. Okay, so totally we have 9 features in this particular data set. Okay, so each column represents one feature, and the target variable will be whether the person will get a job or not. So one type of the target will be yes, the person will get a job, and the other type of the value which we can have is no, the person will not get a job. Okay, so that will be our target variable, and these 9 column represents our features. Now we need to find whether a person will get a job or not by analyzing this particular data. Now all these columns are not important for us. Some columns are important, whereas some columns are not important. Now let's try to understand which columns or which features are important for making this prediction. So let's try to understand these columns individually. So first column is the name of the person. So now we can think logically. So the job offering that has been there is for the role of software engineer. Okay, and now let's try to see which columns are important for us. First column is the name of the person. So if we think The name of the person has nothing to do with whether they will get a job or not, right? So the person can have any name, and their name does not influence whether that person will get a job or not. So this particular column, this name column, won't be that much important for us. So, or in other words, it won't be important at all. And the second column is the degree of the person. So the first person, the person A, has studied bachelor of engineering, and the second person has studied master of engineering, maybe in computer science or information technology. Third person has studied MCA, and the fourth person has also studied BE. Now let's try to see whether the degree is important for that particular role. Yes, we know that the degree or the educational qualification of a person is very important to decide whether that person will get a job or not. So this second column will be very important for us. So this column is required for our prediction, and the college they studied. So I've just named some colleges, and we know that the college that they are studying will actually influence whether they would get a job or not. If the person is from a high tier college, there is a high chance that that person will get a job, that particular job. So it is obvious, right? So this particular column is also essential. And now we have the three programming languages. So for a software engineer, it's important for them to know programming languages, right? So these three columns will be important. So whether a person knows C, C++, and Python. So let's say that this tick, green tick, represents that the person knows C programming, and X mark represents that that person does not know that particular programming. So in this case, all the four people knows C programming, and two people doesn't know C++, and so on. Okay, so X represents the person who does not know that particular language. So these three columns are important for our prediction to determine whether the person will get a job or not. Okay, so these three columns are important. Now we have the height and weight column. So we can confidently say that the height and the weight of the person doesn't influence that they are going to get the job, right? So it is not relevant to that particular use case. So the height and weight of a person does not influence whether a person will get a software engineering job or not. So these two columns are not required. And finally, the number of backlogs. So this is very important, right? If a person has more number of backlogs, or if a person has more number of arrears, then it's most probably that he may not get a job. And if a person does not have any backlogs at all, then the chance or the percentage that that person will get a job is really high, right? So this will be a very important feature for us. So out of these nine features, we have excluded the three features. One is the name column, height column, and weight column, and the remaining six features are important for us to determine whether the person can get a software engineering role or not. Now we need to give a numerical value to emphasize the importance of these columns, and this is where weights will help us. Okay, so we will assign some particular numerical value to these columns. So when it comes to name, height, and weight, we know that these columns are not important, right? So in this cases, we can give the value of 0 to weight. Okay, for name, height, and weight, we can give the weight value as 0, and different columns have different weight values. So each of these columns will have different weight values, and it is not a common value. So if there are about nine features, you will have nine different weight values, and this weight value is not constant for different columns, because we know that each column has separate importance. So say for example, the degree has a high weightage, and college also has some weightage, and this programming. So these three columns as a high weightage when we compare it to degree and college and so on. And number of backlogs. This number of backlogs has a negative impact on the job of the person, right? If the person has 10 backlogs, then we need to say that that person is not likely to get that job. So in this case, the weight will have a negative value. So the positive columns or the positive features will have positive weights. So the desirable or the favorable columns will have the positive weight values. The undesirable columns, or the undesirable columns in the sense is the number of arrears. So it will have a negative weight value. So that is one main thing that you need to understand. So positive weights means that is a positive result, and negative weight means there will be a negative result if we have the high number of values in that particular column. So that's one main important thing that you need to understand. So weight is helpful for us to decide which column or which feature will influence the output. Here the output will be whether the person will get a job or not. Okay, so this is the importance of the weight of a model. So this is nothing but the slope of the line that we are talking about. So here I've told you, right, y is equal to wx plus b, and this slope actually represents this importance. Okay, so in this case, the example I've taken is x represents the number of years of experience, right? So w will be the weight. So how much this particular column or feature will be helpful for us to predict the salary of the person. So that is meant by the weight of the model. Okay, so I hope everyone is clear to this particular mark. So as I've told you, weight decides how much influence the input will have on the output. So the number of weights that we have is equal to the number of features that we have in a particular data set. So let's say that y is equal to wx plus b. So this is the equation of a simple line. Okay. So in this case, we have only one feature, which is x, and we have the output variable as y. So in this case, x represents the feature or the input variable, and y can be the target or output variable, and w can be the weight, and b can be the bias. So you can also call this w as a slope and b as the intercept when it is a linear model, when it is a simple line. Okay, so in this case, let's say that x represents the number of years of experience of a person and y represents the salary of the person. Now we may also have multiple features, as I have told you, right? So in the previous slide I have told you, I have taken an example where we totally add about 9 individual features, right? So similarly you can have multiple features. So in this case we just add only one feature, and in some cases we will have multiple features. So when you have multiple features, the equation of your model will look something like this. So y is equal to w1 into x1 plus w2 into x2 plus w3 into x3 plus b. Okay, so x1 represents, it may represent the college from which they have studied, and x2 represents whether the person knows c programming or not, and x3 represents the backlog of a person. So this would be the equation when you have three different features. So the number of weights will be equal to the number of features that you have, and bias will be a one single value. Okay, so weight can be an array. So if you consider w1, w2, w3 and so on, all these weights can be considered as an array. Okay, so whereas b will be a single value. So you can include w1, w2, w3 together, and you can call them as an array, but b will be a single value. Bias will be a single value in this case. So the one main thing that you take note of here is, in the case of a simple line, when you have a single feature, you will have only one weight value or slope value, and when there are three different features, you will have three different weight value. Okay, and this weight value represents how much importance this x1 has on the target variable y. Okay, and x2 and w2 represents the how much importance does x2 have on the target variable y. So if x1 represents, let's say that x1 is the number of programming languages that a person knows. Let's say that a person knows 4 programming languages. So in that case, w1 will be a positive value, because it is a desirable character, right? So the number of programming languages. And let's say that x3 represents the number of backlogs that a person has. So more the backlogs of a person, it is unlikely that he is going to get a job, and hence we can say that w3 will be having a negative value. So we can have both positive values and negative values for the weight of the model. So that's another main thing which you need to take note of. So that's it about weights of the model. Now let's try to understand about the bias of the model. So you can call this bias as the offset value. Okay, so the other name for bias is offset, and bias is the offset value given to the model. Bias is used to shift the model in a particular direction, and it is similar to a y-intercept in a simple linear regression model, and b is equal to y when all the feature values are 0. Okay, so this is a definition and a detailed description of bias. And let's try to understand about what is meant by this bias. So as I've told you, it is an offset value of the model. So as you can see here, both of these models have some bias value, which is b, right? And it is used to shift the model in some particular direction. So I'll explain you what this exactly means, and we can call this as y-intercept. So in my previous videos of linear regression, I have explained you what is meant by this y-intercept. I'll also give the link for my videos in the description, where I have explained you about linear regression. So if you have some doubts, you can check that as well. So this bias is similar to the y-intercept that we have, and the b value will be equal to y when all the feature values are 0. Now let's try to understand this with an example. So we know that the equation of line is y is equal to mx plus c, and as you know, I have replaced the slope value, the m value, with w, and intercept value with bias b, right? So x represents x value, y represents y value, w represents weight, and b represents bias. So this will be a particular line. For this particular line, you will have a particular value for w and b. If you take a different line, so I'll just draw a different line here. So if you have a line like this line, so let's say that this is a straight line. So this line will have a different slope value, different w value, and different intercept value. And let's say that we have a line like this. So this particular line will have a different slope value, again a different weight value. Okay, so now what happens is, so sometimes if you change the slope, the orientation of the line will change. Okay, so slope is nothing but dy by dx. Dy by dx in the sense, when the x value changes by a particular unit, what will be the change in the y value? Let's say that here the x-axis value is 2 and the x-axis value, the second x-axis value is 3. And if the x-axis value changes from 2 to 3, what will be the change in the value of y? So that is called as the slope of the line. So we everyone of us knows this, right? So if you are not clear about this, kindly watch my linear regression video, so it will make clear sense to you. So as I've told you, so slope is nothing but the change of value in y when x changes. So if you change the slope of the line, if you change the slope of the line, your orientation of the line will change. Okay, so if you change the slope value, you will get a line like this. So let's say that we get a line like this. So this line will have a different slope, and this particular line will have a different slope. And if you have a line like this will have a different slope. So changing the slope of the line or changing the weight of the line will change its orientation. So that is called as the weight of the line. And then we have the bias. So bias is this particular region. So what is the distance between this particular point from origin? Okay, so in this case you can say that this particular value is 3, right? So we have 2 and 4 as coordinates, and this particular line starts from this point, and this represents the bias of the line. So this is also called as the y-intercept. Okay, so whenever you change the slope of the line, your orientation changes, but you cannot change this particular position of the line. Here the line starts from 3, and no matter how you change your slope, your position of this particular line won't change. So it will start from this point exactly 3. And if you want to change this particular intercept value, you need to change the value of c, right? So that is why we have this bias. So if you change the bias value, let's say that we have a bias value as 6. So in that case, what will happen is your line will start from this particular point and will be looking something like this. Okay, and the slope will be the same in both the cases if you have the same value for w. And if you have the intercept value or the bias value as 4, your line will changes. Sorry, your line will start from this particular point. So this is the importance of bias value. So sometimes we need to shift this particular line in the upward direction or lower direction. So in case you have intercept value as 2, your line will start from here, right? So no matter what, no matter how much you change your slope, your this particular point won't change. So if you want to change this particular point from where your line starts, so in that case you need to change the bias value or intercept value. So that is the importance of this bias. Okay, so changing the values is really important for us when it comes to machine learning, as it is nothing but the optimization techniques to find the better values. So this is the importance of bias value. So you can also easily find this intercept value. So intercept value is nothing but let's try to put the value as a 0 for x. Okay, so let's try to take this equation and let's put x value as 0. So what will be the this equation when x is 0? So w into x, which is w into 0, will be 0, and y will be equal to b, right? So b is nothing but the value of y when x-axis value is 0. So now you can see this equation. So let's try to take this particular point. So let's try to find what is the coordinate of this point. So this coordinate of this point is nothing but b 0 comma b, right? Where 0 represents the x-axis value and b represents the y-axis value. So I'll just write it here. So this particular point b represents 0 comma, so 0 comma b, or it's 0 comma 3 to be exact. Okay, so I'm not good at writing, so just tolerate this. So it's 0 comma b. So this 0 comma b represents this slope of the line. So you can also say in different words that bias is equal to y when x is equal to 0. Okay, so that's what I have given in this particular equation. As you can see here, b is equal to y when all the feature values are 0. Here feature value is nothing but x, right? So that is all about weights and bias. So bias is the offset value that we give to our model. So this is that particular offset value, and this bias value is used to shift the model in a particular direction. So in this case, when it comes to a linear regression, it is helpful for us to shift the model in the upward direction or the downward direction. So we want our line above this point or below this point, and so on. And there are models like sigmoid curve. So in that case, the sigmoid curve will be shifted in the left direction or the right direction when we change the bias value. So for a line, when we change the bias value, your line will move in the upward direction or lower direction. Okay, so the line will shift in the upward direction or lower direction, but when it comes to a sigmoid curve, your curve will shift in the left direction or right direction when you change the bias value. So that's a topic for discussion in some other video, but just try to understand this. When it comes to linear regression, the changing the bias value will change the direction of the line, sorry, the this particular point in the upward direction or lower direction. Okay, so that is all about bias. So bias is the offset value, and it is used to shift the direction of the model. Okay, and it is similar to the y-intercept. So this is nothing but the y-intercept. Y-intercept in the sense, what is the value of y when the value of x is 0. So that's what I have given here. So this is all about the slope and intercept of the model, or the weight or the bias of the model. Okay, so these two parameters are hence called as the model parameters, and this model parameters differs based on the data that we have. If we use different data, then we will get different values for weights and biases. Okay, so this is all about model parameters. And the next parameters that we have is hyperparameters. As I have told you, the two hyperparameters that we have are learning rate and number of epochs. And as I have mentioned earlier, we will try to reiterate the model with the data. So we will try to fit the model again and again with the data. Let's say that we have 100 iterations. So 100 iterations in the sense, we want our model to go through the data 100 different time in order to find the best weight value and the best bias value, so that our model can make better predictions. Okay, and hyperparameters are helpful for optimizing the model. Optimization is nothing but a technique which is used to make better model parameters, so that we can make better prediction. So now let's try to understand about the learning rate and the number of epochs. So the learning rate is a tuning parameter in an optimization algorithm that determines the step size at each iteration while moving towards a minimum of a loss function. So this is the definition of learning rate. So just look at the word tuning parameter and optimization algorithm. So what happens is, we need to change the values of weights and bias, right, in order to get a better value. Let's say that this particular point represents the initial weight. So we are starting from this initial weight, and let's say that this initial weight w is not a good parameter. So that particular weight value is not giving us good prediction. So that particular weight will have high loss function. So if you don't know what is meant by a loss function, I have already made a video on loss function. I'll also give that particular video link in the description, so do check that out as well. So if a model is not performing well, then it will have a very high loss function. If a model is performing well, if it is making accurate prediction, in that case the loss function value will be very low. It will be 0 and so on. Okay, so high loss function value means the model is not working properly, and low loss function value means the model is working properly. So from this point, we need to reach to this particular point where the loss function value is minimum. Okay, so what we will do is, we will repeatedly change the weight value to see what will be the optimum parameters, or optimum parameter value or the weight value, so that we can get a minimum loss function. Okay, so the idea here is to minimize the loss function. So j of w represents the loss function, w represents the weight of the model. So we need to change the weight of the model so that we get a minimum loss function. So minimum loss function means accurate model, right? So we start from this particular point, a particular initial value, and we'll try to change this value and so on, so that we can reach this global minimum. Okay, so global minimum is the point where the loss function value is minimum. And there is a change in the weight value, right? So this change in the weight value can be, let's say that the weight value is 10. Okay, so let's say that we have a linear regression model, and this equation of this linear regression model is y is equal to 10x plus 3, where 10 represents the weight and the 3 represents the bias value. Now we need to repeatedly change this weight value. Let's say that we change the weight value by 1 in each step. So this one direction represents one step, the next direction symbol represents another step, and so on. So we need to come in this direction, right? So each step will reduce your value, or it will reduce the value of our weight by 1 unit. So if you start from 10 unit, so each step you will take will reduce your value by 1 unit. So the second iteration when you do, your weight value will be 9. So that represents your linear equation will be y is equal to 9x plus 3. And the next iteration, again your weight value will be reduced by 1 unit. So in this case, your linear regression equation will be y is equal to 8x plus 3 and so on. So in this case, the change that you are giving to your model is 1 unit, right? And this amount of change that you are giving is called as the learning rate. So often we want to give that much learning rate. So the learning rate that we will give will be in the range of 0.01 or 0.001 and so on. And it completely depends on the data set that we have, and it depends on the magnitude of the weight that we have. So if you have a weight value around 1000, In that case, you cannot use a learning rate as 0.01, right? So it would be very tedious in that case. So it depends on the magnitude of the weight that you have, and it depends on the data that you have. So this is called as the learning rate. So in each iteration, we will try to change the weight value, and we will try to see whether the loss function is reduced or not. So the change that we are imparting to the weights is called as the learning rate. So how much value or how much change in the value that we are giving to our parameters. So now read this definition again. So the learning rate is the tuning parameter in an optimization algorithm. So that determines the step size. So step size is nothing but the change that we are imparting at each iteration while moving towards a minimum of a loss function. So the minimum of a loss function represents the global minimum where the loss function is minimum. So whenever the loss function is minimum, that means the model is making accurate prediction. Okay. So this is an example of a gradient descent. So this represents a gradient descent algorithm, and a gradient descent is an example of a optimization algorithm. So in the upcoming videos, we will discuss in detail about gradient descent. And if you don't understand about gradient descent, it's completely fine. I'll make a separate video on this gradient descent, and it is a very important concept in machine learning. So in several models, we use gradient descent as our optimization model. So it is very important for us. And I'll explain you clearly what is meant by this gradient descent. For now, try to understand that learning rate is the amount of the change that we are imparting to the model in each step of the training process. Okay, so this represents the learning rate. And now we have the number of epochs. So number of epochs represents the number of times the model iterates over the entire data set. Okay. So let's say that we have 100 iterations. So in that case, what we will do is in each 100 steps, we will try to change the parameter value by some certain amount. So in that case, we will give some particular learning rate value. And number of epochs is like the number of iterations. So it is very simple. The number of times you want your model to go through the data. So this represents the number of epochs, and you can give any values for your epoch. So you can give 100 iterations, or you can give 1,000 iterations, and so on. And it also depends on the data that we have and the model that we are choosing, and so on. Okay. So if you give a very high number of epochs, there is a high chance that your model will overfit. And if you have a very low number of epochs, then there is a chance of underfitting. So we need to find the optimum value of this number of epochs and learning rate. And not having a proper learning rate or the number of epochs will result in either underfitting or overfitting. So we need to find a proper optimized value for learning rate and number of epochs. And for this, we use some techniques called as gradient descent and so on. Okay. So these two are called as the hyperparameters, the learning rate and number of epochs. So that is for this particular video. So I hope you have understood about the model parameters and hyperparameters. So it is the same slide that we had before. So now you can see this, or you can read this definition again, and you would have gotten a better understanding. So model parameters are the parameters of the model that can be determined by training with training data, and these can be considered as internal parameters such as weights and bias. Okay. So we know that once we train the model with the data, we will get this particular parameters. And hyperparameter is outside the model. So this hyperparameters are all about controlling the learning process, right? So we have a learning process where we will try to optimize the values of weights and bias. So this learning process is controlled by the hyperparameters values such as learning rate and number of epochs, and these are very useful for finding an optimal model, and hence these are called as an external parameters because they are not directly involved with the models, whereas the model parameters are directly involved with the model, and hyperparameters is just a controlling factor for the learning process. So that's it about the two types of parameters that we have, which are model parameters and hyperparameters. And I hope you are clear with this. And if you have any doubts, please mention in the comments. I'll try to reply to your comments and try to clarify your doubts. So that's it from my side, and I'll see you in the next upload, and thanks for watching.